Hi, in this demonstration we're going to wrap up our SQLite discussion from the last unit by connecting our database to our user interface so that everything works the way we had it before. First of all, you can notice that I have the parts model left, but I removed all the other model classes. And I've added 3 methods, the first of which we're not really going to use. You can use it for troubleshooting. What this does is returns a Boolean value, yes or no, essentially, whether or not the inventory table contains a particular bin. So this could be useful in troubleshooting. I've used it, but I'm not actively using it right now. We've also got 2 update methods. These call update queries against the database. The first is update inventory quantity, and the second is update catalog reorder quantity. We know that the user could change these numbers at any given time. So let's look at these methods. In partsmodel.m, the first of those is update catalog reorder quantity. One thing you'll notice when you're looking at the new version of the model is that each of the methods actually opens the database before it does its job and then closes the database. So this way, the database connection is only open when each method is doing its thing, and it ensures that the database is closed before we exit the application. You recall that in main view controller, we were opening before we did anything and then closing after we did everything. Here, rather than doing that, we're just opening and closing. We're wrapping the entire method in these opens and closes. So update catalog reorder quantity is pretty simple. It's an update query, update catalog, set reorder equal to that quantity, where the part number is equal to so-and-so. So it's the reorder's integer value and the part number. We prepare that SQLite 3 statement, the update statement, and then we check to see if the result is SQLite OK, and then we step the update query if it is. If it is not, we're just going to log out the error message associated with this. The SQLite 3 error message logs out the last error that happened on parts database. We finalize the update query and then close the database. The next one we want to look at is inventory contains bin. Very quickly, this is just a select query. We prepare the statement, and then we run the statement only if the result is SQLite OK. We run the statement, and we see that whether or not it returns a row, at least one row. If it returns one row on select from inventory where bin equal whatever, then there was a row, therefore there was a bin, therefore that bin is in inventory. So the return value is yes. Otherwise, we assume the return value is no, and we return that after we close the database. When we have a return value, we must close the database before we return. Otherwise, the database will not be closed, and that is bad. And then update inventory quantity. This is actually the quantity in inventory and NS number passed in for part ID. Now, we know we made a slight adjustment to that inventory select, and I'll show you that in a moment, but we're going to get the part ID so that we can pass it back to this. We don't have the part number, we don't have the name of the part, but we do have the part ID now. So we open the database and we set this up to say update inventory set quantity equal to the new quantity, where the part ID equal an integer. So these are both coming in as NS numbers, so we set them both to integer values and unbox them, and then prepare the update query as always, get the result. If the result is okay, we step the update query, otherwise we log out the error, finalize the update query, and close the database. So this is pretty simple. Now let's look at where we get that part ID from the inventory select. So this is, let's see, inventory, all inventory parts. So here we go. Now we're selecting out the part ID, part number, name, bin, and quantity. So 5 fields are being selected. From the catalog, inner join inventory, where the catalog ID is the part ID. So we could have selected the catalog ID or the part ID here, because really they refer to the same integer, but I'm just selecting out the part ID. And then when we create that values array, we use the part ID first. So it's the 0th in the array, and then 1, 2, and the third index is the index from the actual select query with 4. And then we get the bin number, and everything is the same except we have inserted the part ID into the result of the result set of the selection and written it into that mutable dictionary that we return as an NS dictionary. Okay, now, everything now, instead of being parts catalog and inventory and things like that in the model, if we look at our model header, if we look at the main view controller header, we can see that we've gotten rid of the import statements for everything else and just imported parts model and created one property, parts model, and we're calling it model. Now, if we look at the main view controller M, we'll see in view did load, this is for testing only. Well, first, we delete all the parts from the catalog and the inventory, and then we set 2 parts in the catalog. So we've called delete all parts from inventory and delete all parts from catalog against the model. And then we call add to catalog, and we've added 2 parts here. Now, because we moved all the open and closed database statements into the methods of the model, we don't need to do it here, and we don't want to do it here. And that's it. So view did load is vastly simplified. All we're doing here, and we won't do this in the production version of the application, is just adding 2 parts. We've cleared out the database to give it a fresh copy, and then just added 2 parts. Okay, so the important thing here, though, is that we no longer have the catalog and the inventory tags going from the view controller or our main view controller back to the model. We only have one. So this is self.model. And of course, we saw the last time that we lazily instantiated as parts model alloc init. Okay. So now the only real changes that have to happen are in the parts list view controller. So rather, the main controller is still the self.navigationcontroller.tabbar controller. There are no changes necessary to adding controller and detail controller because they're just pointing back to the subsidiary view controllers. But in the M file, in the implementation, everywhere we had main controller catalog or main controller inventory, we have replaced it with main controller model. And we have very, very few changes. For example, this is essentially the same method, adjust inventory with part number, blah, blah, blah. We just go, to bin has part as we did before, but we're doing it against the main controller model, all inventory parts. And now we know that if we get all inventory parts, we can check for a bin in inventory. If current inventory all keys, this is this object here. If current inventory all keys contains the object pbin, the bin exists. Its current inventory object per key gives us the parts info. And here we get the part ID so that if the bin has the part, we're going to update the part ID by just calling main controller model update inventory quantity, box quantity for part ID, part ID. Very cool. And this actually is much simpler than what we did before. If the bin doesn't have the part, we just add it to the bin. And if the bin is not in inventory, we just add it to the inventory. So these two are exactly the same thing as they were before. And the add to inventory method in the model handles the difference between we don't have a bin or we have the bin but we don't have the part. So this is taken care of by the model just exactly as it should be. And we log out the inventory by calling all inventory parts and then just logging out that if the parts changed. This is essentially the changes that are necessary. Main controller model rather than main controller parts inventory or main controller parts catalog. Reorder quantity change to for part is the reorder quantity. We set that number to a number with integer and we box it up into an NS number. And then we call update catalog reorder quantity against the model. So here's the reorder quantity and for the part. In the segues, there have been some changes in the detail of how we looked at the object, the indices in this object. It's 0, 1, and 2 The quantity we're setting to 0, and we're setting pbin to catalog only. And since the detail here is a catalog detail rather than a parts inventory detail, which we haven't yet implemented, we recall in the storyboard we don't have an inventory view controller yet, but we will. This is just the catalog view. So in the catalog view, we're just going to say catalog only. There's probably some better way to say that, as in this is the template of a part rather than the actual part. But let's not get into that detail that we can solve later at this point. So now when we run the application, we're going to see that everything looks the same. We're getting our data, though, this time now from the database rather than from a hard-coded model. So we've got part number 002 and part number 001. If we go into part number 001, and let's change the reorder level maybe to 30, and we'll say done and adjust inventory. Now if we go back out, parts number 002, parts number 001, the reorder level is still 30. We got it from the database that time. Let's go and in part number 002 perhaps, let's say that we have a quantity of 150 now, and we're placing it into an inventory bin actually let's just call this PRB, part room bin 00125, and just to make something up. And then if we say adjust inventory, we can see that the inventory shows up in PRB 00125, and this is the part ID. We're up to 59. It really doesn't matter. It just matches. We know that it matches the part that's just been created. Remember that when we auto increment, it's not going to repeat any previously used number. So in our testing, we have added 59 parts to the catalog. PN002 in the second part, and there's 150 of them. This is the important thing, is in listing out the inventory, we can see that bin 00125 in the parts room has 150 of PN002, which is, oh, by the way, called second part. So there we go. This is the run of the application, and now at this point, everything is working exactly as it did before, with the exception that we have replaced the model with a SQLite 3 database. Thank you very much.